For today's lesson, we will be going over the average shear stress. Let's look at some of the learning outcomes. We want to define and understand average shear stress and use the formula tau is equal to V over A to solve average shear stress problems. Average shear stress is equal to V over A, and if we take a random section of this object, then V is the total shear stress on the object, and A is the cross-sectional area. Average shear stress has the same direction as V, and it assumes that shear stress is uniform across the section. It is also sufficient for some design situations, for example, simple connections in steel and wood. Here are some examples of direct shears. We have a single shear. This shows two lap plates. Since the plates are thin, the moment due to eccentricity of P, which is caused by the force not being in direct line of the plate, is negligible. Next we have a double shear, which shows a double lap joint. Let's take a look at this example. Determine the average shear stress in the 20 mm diameter pin at A and the 30 mm diameter pin at B that supports the beam in the figure. First, we will set up our positive axes. We need to find all the forces in the beam. We will find the moment at A to get the force BC. Using this, we can use the summation of forces in the x direction to find AX. Lastly, we will use the summation of forces in the y direction to find AY. We will look at pin A first. We will find the resultant force at A, and since the pin is a double shear, the shear stress is divided by 2. The resultant force at A is 21.36 kilonewtons, and the shear stress will be 10.68 kilonewtons. Now we can find the area of A, and since the diameter is 20 millimeters, our radius will be 10. This will give us an area of 100 pi millimeters squared. Now we can use everything to find the average shear stress using this formula, which will give us 0.034 kilonewtons per millimeter squared. Next, we will look at pin B and find the force at B. Pin B is a single shear, so the force is equal to the shear stress. This gives us a shear stress of 12.5 kilonewtons. Now we can find the area. Since the diameter is 30 millimeters, our radius will be 15 millimeters. This gives us an area of 225 pi millimeters squared. We can then use these to find the average shear stress, which is equal to 0.018 kilonewtons per millimeter squared. Using the formula, we were able to find the average shear stress at pin A, which was 0.034 kilonewtons per millimeter squared, and pin B, which was 0.018 kilonewtons per millimeter squared.